Alright, and welcome back. In this video, we are going to be going through Chapter 5, Section 5, titled Trapezoids. By the end of this video, we should be able to apply the definitions and identify the properties of a trapezoid and an isosceles trapezoid. So without further ado, let's have out those guided notes. Let's begin. So a trapezoid. A quadrilateral with exactly one pair of parallel sides is a trapezoid. The parallel sides are called bases, and the other side are called legs. Notice how only one pair of parallel sides here. So this is not a parallelogram because we do not have two sides that are parallel. We only have one pair of sides that are parallel. The parallel sides, again, are the bases, and the other sides are going to be called the legs. We also have a isosceles trapezoid, and an isosceles trapezoid is going to be a trapezoid that has congruent legs, just like an isosceles triangle. We're just going to take it up a notch, and now we have isosceles trapezoids. So we have a theorem that base angles of an isosceles trapezoid are congruent. So if trapezoid ABCD has segment AB congruent to segment DC, then we're going to know that angle A is congruent to angle D, and angle B is congruent to angle C. Again, it's very similar to triangles that have three sides. Now we're talking about an isosceles trapezoid that has four sides, but similar properties are going to appear again. We also have what's called the median of a trapezoid, and the segment that joins the midpoints of the legs of the trapezoid is the median. Notice the difference between the median of a trapezoid and the median of a triangle. Remember, the median of a triangle, as pictured all the way to the right here, is going from the vertice going down to the midpoint of its base. The median of a trapezoid is connecting the midpoints of the legs. And the median of a trapezoid has two special properties here. One, it's parallel to the bases, which means that, MN, which is the median, is parallel to ZO and DI, and two, has a length equal to the average of the base lengths. So if trapezoid ZOID has a median MN, again, we're going to know that segment ZO, MN, and DI, all three of those are parallel, and we're going to know that segment MN, that median, is half of the average here. It's half of the average. So in example 1, we given that in parts A and B, a trapezoid and its median are shown. We want to find the value of x. Well, for A, we have bases of 12 and 6, and we have the median of x. So we know that it's going to be half of 6 plus 12, so that median has a length of half of 18, which is going to be 9. For B, we have the bases of x plus 12 and 7x minus 2. We have the median of 5x. So we can take half the sum of x plus 12 and 7x minus 2, and that's going to be equal to 5x. So as we substitute in here, we end up with the value of x is equal to 5. Again, because we're taking half of each base. So we took half of x plus 12, which is right here, and 7x minus 2, we add them together and we take half of it, and that's equal to our median of 5x. In C, we are given that we have a trapezoid. We know it's an isosceles trapezoid because AB has a length of 8 and CD has a length of 8. So we can use the idea and the properties of isosceles trapezoids knowing that we have congruent angles. Well, we're going to know that measure of angle A is equal to the measure of angle D because, again, it's an isosceles trapezoid. We can fill in as we go. The measure of angle A plus the measure of angle B is equal to 180 degrees because they are same side interior angles along a transversal, I should say. Well, we know that 70 plus the measure of angle B is equal to 180. And then we're going to end up with the measure of angle B is equal to 110, which is the measure of angle C, which stands for our value of x. With this in mind, please work on problems 1 through 8 on the guide and notes, and resume when you're ready to move forward. Here in example 2, in triangle ABC, we are given that the length of AX is equal to the length of XM, which is equal to the length of MB, and we're also given that the length of AY is equal to the length of YN, which is equal to the length of NC. For part A, if the length of XY is equal to 6 and the length of BC is equal to 18, we want to find the length of MN. And then for part B, if the length of XY is 12 this time, we want to find the length of MN. Well, as we scroll down to our solution, we know that the segment MN is the median of trapezoid BXYC. So trapezoid BXYC is provided. We know that XY is equal to 6 and BC is equal to 18. So MN is going to be half the sum of those two segments. So half of 6 plus 18, which is going to yield 12. Let me erase this now. That way we don't get it confused with part B. For part B, again, xy is equal to 12, and we want to find the length of MN. So xy is 12, and we know that xy joins the midpoints of the two sides of triangle AMN. Well, we know that since xy connects the two midpoints of the two sides of the triangle AMN, that it's going to be half of the base of MN. So xy is equal to half the base of MN. We know the length of xy is 12, and again, that's still equal to half of our base MN. So we double both sides, and we end up with the length of 24 for segment MN. With this in mind, please work on problems 9 through 12 on the guide. Keep making yourself proud. Please let us know if you have any questions, and we'll talk to you soon.